In the middle of the 17th century, the world of natural philosophy was caught between two worlds: the mystical traditions of alchemy and the emerging clarity of experimental science. For centuries, alchemists had sought to uncover the secret principles of nature, speaking in riddles and cloaking their discoveries in metaphor. They claimed mastery over hidden elements, boasted of elixirs and philosopher's stones, and divided matter into a small set of primal substances: sulfur, mercury, and salt. Yet a new age was dawning. Observation, experiment, and reason began to challenge authority and dogma. And into this turning world stepped Robert Boyle, a thinker with both the patience to listen to tradition and the courage to question it. In his work The Sceptical Chymist, Boyle did something audacious. He took the revered doctrines of the alchemists and subjected them to sharp examination, testing whether their claims held up to evidence and reason. Boyle begins with a simple but profound question: what is matter really made of? For the alchemists, the answer seemed settled. They taught that all natural bodies arose from three fundamental principles: sulfur, mercury, and salt. These were not the common substances of the laboratory but rather abstract principles. Sulfur as the principle of combustibility, mercury as the principle of volatility and fluidity, and salt as the principle of solidity and fixedness. By mixing these, they claimed, nature fashioned metals, minerals, and all other compounds. But Boyle was not content to accept their word. He saw that although alchemists had written endlessly about these principles, their accounts contradicted one another. Some multiplied principles beyond three, others reduced them to two, and still others hinted at an infinity of subtle essences. Their books were filled with obscurities and allegories. Instead of clear definitions and consistent demonstrations, there was vagueness and secrecy. Boyle resolved to test these doctrines with careful thought and experiment. His goal was not merely to criticize but to build a foundation for what he called chemistry, what we would now call chemistry, based not on the authority of old masters but on the firm ground of observation. To do this, he first considered the claim of the tria prima: sulfur, mercury, and salt. Were these truly the fundamental ingredients of nature? If so, one would expect experiments to reveal them consistently. A chemist might, for example, decompose a plant or a metal into these three constituents. Yet Boyle noted that while alchemists claimed to find them, the results varied widely. In some analyses, sulfur seemed absent. In others, mercury was nowhere to be found. And sometimes what they called salt was nothing more than an accidental residue. This inconsistency suggested to Boyle that the supposed principles were not truly elemental, but rather secondary products, things formed during chemical operations, not fundamental building blocks. Fire, distillation, and corrosion could transform matter in countless ways, generating new substances that alchemists mistook for original principles. Boyle urged his readers to distinguish between principles discovered by reason and experiment and substances imposed by tradition. He argued that just because sulfur or mercury could be extracted in one process did not mean they existed preformed in all natural bodies. The fact that burning wood leaves ashes does not prove that ashes were hidden in the living tree. Rather, ashes are what remain after the fire has consumed the more subtle parts. With this reasoning, Boyle began to dismantle the authority of the tria prima. But he did not stop there. He turned also to the Aristotelian tradition, which divided all matter into four elements: earth, water, air, and fire. This doctrine had held sway for nearly 2 millennia, passed down from the ancient schools into medieval science. Yet Boyle saw in it the same weaknesses as in the alchemical principles. When subjected to experiment, the four elements dissolved into uncertainty. What, after all, was meant by earth? Was it the soil beneath our feet, or the dry and heavy principle of solidity? And fire, was it the flame that consumed fuel or an abstract principle of heat? The definitions shifted depending on the philosopher. And when chemists attempted to reduce bodies into these four elements, the results were no more consistent than with the tria prima. Boyle's conclusion was radical for his time. Neither the Aristotelian elements nor the alchemical principles deserved the status of fundamental constituents of matter. They were, at best, useful descriptions of qualities, but not true explanations. Instead, Boyle proposed a new approach. Matter, he suggested, should be understood as composed of corpuscles, minute particles of varying shapes, sizes, and motions. These corpuscles, when combined in different structures, gave rise to the variety of substances observed in nature. Unlike the vague principles of the alchemists, corpuscular philosophy offered a mechanical, intelligible framework. The beauty of this idea lay in its flexibility. By rearranging particles, nature could produce the hardness of stone, the fluidity of water, or the brilliance of metal. By altering the motions of these particles, fire could consume wood, or acids could dissolve minerals. Chemistry, then, was the study of how corpuscles were arranged and how they could be transformed. Boyle knew that this philosophy was not yet complete. It would take generations of experiments to refine the corpuscular view into the atomic theory that later triumphed. But by questioning both alchemy and Aristotelianism, he cleared the ground for a new science. Thus begins the Sceptical Chymist, not with dogma but with doubt, not with final answers but with careful questioning. Boyle's skepticism was not destructive but creative, for by refusing to accept untested doctrines, he opened the path to discovery. The Aristotelian doctrine of the four elements, earth, water, air and fire, had reigned for nearly 2,000 years. It was so deeply woven into the fabric of European thought that to question it seemed almost reckless. Physicians prescribed treatments based on its balance of hot, cold, wet and dry. Natural philosophers invoked it as the key to explaining growth, decay and even the heavens themselves. But Robert Boyle was not intimidated by its age or its prestige. He knew that longevity alone is not proof of truth. A belief, however ancient, can endure not because it is accurate but because it is comfortable, authoritative, or unchallenged. Boyle therefore approached the Aristotelian elements with the same critical eye he had directed toward the alchemists' sulfur, mercury, and salt. The first difficulty he noted was ambiguity. When philosophers spoke of earth, what exactly did they mean? Was it the soil that nourishes plants, or a more abstract principle of solidity and dryness? Water, was it the liquid that flows in rivers or simply a quality of coldness and moisture? And fire, was it literal flame or an incorporeal essence of heat? Depending on the author, the meaning shifted, and this very uncertainty made the doctrine weak. A science built on shifting definitions could not stand. The second problem was lack of experimental proof. If earth, air, fire, and water were truly the fundamental ingredients of all matter, then it should be possible to reduce complex substances back into them through careful analysis. Yet when chemists attempted to do this, burning, distilling, dissolving, they never obtained clear universal results. A plant might yield oils, salts, vapors and residues, but which of these was earth, which water? If water was an element, why could it be broken down into vapors and salts through distillation? The supposed simplicity of the elements dissolved under the hand of experiment. Boyle insisted on a crucial distinction. Qualities are not substances. Heat and cold, dryness and moisture are indeed real features of bodies, but they are not themselves the ultimate matter from which bodies are made. They are properties, effects that arise from the arrangement and motion of smaller particles. To confuse qualities with substances as Aristotle had done, was to mistake appearances for foundations. This insight was powerful. It freed Boyle to look beyond the veil of traditional categories and to imagine matter as composed of something deeper, something hidden beneath qualities, corpuscles or particles. These corpuscles were not abstract principles but real, physical entities, tiny bits of matter with definite shape, size and motion. By combining in diverse structures, they could produce all the qualities observed in nature. Boyle likened this to the way letters of an alphabet, though few in number, can be arranged to form countless words and sentences. So too, a relatively small variety of particles could generate the rich diversity of natural substances. Wood, metal, stone, flesh, all might be explained as different organizations of underlying particles. But Boyle was no dogmatist. He did not claim to have final knowledge of the exact particles or their precise forms. Instead, he argued for the probability of the corpuscular philosophy as a more reasonable framework than the confused doctrines of the ancients. He invited his readers to test, to experiment, to refine. His aim was not to replace one unquestioned authority with another, but to encourage a spirit of inquiry. Boyle's skepticism was always paired with method. He did not tear down merely for the sake of tearing down. Where the alchemists and Aristotelians had offered obscurity, he offered clarity. Where they had relied on tradition, he demanded observation. And where they had spoken in allegories, he urged plain speech. His criticisms were not abstract quibbles. Boyle pointed to specific examples drawn from the laboratory. Take, for instance, the distillation of wine. When subjected to heat, wine yields spirits, oils, acids, and residues. Which of these should be identified with the four elements? If the spirit is air, then why is it combustible? If the residue is earth, then why does it dissolve in acid? The analysis refuses to align with the doctrine. Or consider water, so long revered as one of the four elements. Boyle observed that when metals were dissolved in acids, new crystalline salts could be formed. Part of the water, had clearly been transformed into something else. If water were truly elemental and irreducible, how could it give rise to substances so different from itself? Even air, which seemed the purest of the four, was shown to be more complex than philosophers imagined. In experiments with combustion and respiration, Boyle discovered that air could be altered, diminished, and corrupted. This hinted that air was not a single uniform element but a mixture of different parts, an idea later confirmed by the discovery of oxygen, nitrogen, and other gases. Through such observations, Boyle exposed the fragility of the four-element theory. He showed that it was not a description of the world as it is, but a speculative framework inherited from antiquity, repeated for centuries without sufficient proof. Its apparent authority rested not on demonstration but on tradition. The implications of Boyle's critique were enormous. By dismantling the two great systems, the Aristotelian four elements and the alchemist's three principles, he cleared the ground for chemistry as a true science. He revealed that the world was more intricate, more surprising, and more open to discovery than the old categories allowed. Yet Boyle was not content with mere negation. Having shown what the elements were not, he sought to suggest what they might be. And so he turned to the mechanical philosophy, the view that natural phenomena could be explained by the motion and arrangement of matter. This philosophy, gaining momentum in Boyle's age, sought to replace occult qualities with intelligible mechanisms. Instead of saying that fire rises because its nature is light, one might say that fiery particles, being swift and subtle, move upward through denser air. Instead of attributing magnetism to hidden sympathies, one might imagine streams of tiny particles flowing from the magnet and acting upon iron. Boyle did not pretend to have all the answers, but he argued that the mechanical view was a fertile path forward. It gave philosophers a way to conceive of matter without resorting to mystical principles. It encouraged experiment because by altering the structure of matter one might predictably alter its qualities. And it harmonized with the growing body of discoveries in physics, astronomy, and medicine, which increasingly pointed to a world governed by law and mechanism rather than by hidden sympathies. Thus Boyle's skepticism was not destructive but transformative. By questioning the authority of Aristotle and the alchemists, he opened the door to a new understanding of matter, an understanding that would, in time, lead to the atomic theory, modern chemistry, and the science of the elements as we know them today. Having exposed the weaknesses of both the Aristotelian four elements and the alchemist's three principles, Boyle turned to what he believed was a more promising path, the corpuscular philosophy. This philosophy proposed that all matter is composed of minute particles, corpuscles, whose shapes, sizes, motions, and arrangements determine the properties of the substances they form. It was not an entirely new idea. Echoes of it can be traced back to ancient atomists like Democritus and Epicurus. But in Boyle's time, it was being revived and reshaped by thinkers influenced by the new mechanical worldview. The universe was increasingly seen not as a theater of mystical sympathies but as a vast machine, operating according to intelligible laws. Boyle was careful, however, not to present corpuscles as a final dogma. He did not claim to know the exact forms or behaviors of these particles. Rather, he treated the corpuscular view as a working hypothesis, a framework that made better sense of experimental evidence than the doctrines it replaced. It was a way of thinking that could guide research, stimulate inquiry, and unify observations. One of Boyle's strengths was his ability to use everyday analogies to make abstract ideas concrete. He likened corpuscles to the letters of an alphabet. A few shapes, when combined in countless patterns, could produce the vast variety of words. Similarly, a relatively small number of particles, by varying in structure and arrangement, could account for the diversity of natural bodies. To a generation weary of alchemical riddles, this analogy was refreshing in its clarity. To give weight to his theory, Boyle turned to the evidence of the laboratory. Fire, distillation, crystallization, and solution. These were not mysterious acts but transformations of particles. When a piece of wood burns, it does not release hidden sulfur, or fire, already present within it. Rather, its corpuscles are rearranged by heat, producing flame, smoke, ash, and gases. When salt dissolves in water, its particles mingle with those of the liquid, dispersing so finely that they are no longer visible, yet still retain their salty taste. Boyle stressed that many of the so-called principles of the alchemists were simply products of processes, not pre-existing elements. The oil, salt, or spirit obtained from a plant in distillation were not fundamental parts hidden within the plant from the beginning. They were new arrangements of corpuscles formed under the influence of heat. Confusing products with elements was a fundamental error of alchemy. Equally important was Boyle's demand for plain speech and openness. Alchemists often wrapped their writings in allegories, claiming to guard their secrets from the unworthy. Boyle saw this as a hindrance to progress. Science, he argued, should aim at clarity, accessibility, and reproducibility. A true chemist should describe his experiments in clear terms so that others could repeat and test them. Only in this way could knowledge accumulate and advance. This commitment to openness was revolutionary. It aligned Boyle with the emerging values of the Royal Society, of which he was a founding member. Nullius in verba, take nobody's word for it. Authority was not to be trusted blindly, truth had to be demonstrated through experiment and reason. Boyle's corpuscular philosophy also had practical implications. In medicine, for example, it suggested that diseases might arise from disordered particles within the body and that remedies should work by altering those structures. In metallurgy, it pointed toward an understanding of how heating and alloying changed the arrangement of metallic corpuscles, giving rise to new properties. In the study of gases, Boyle's own experiments, such as the famous formulation of Boyle's law, which relates the pressure and volume of air, were guided by corpuscular reasoning. Consider his experiments with air. By using a pump to create a vacuum, Boyle showed that air was not a mere absence but a real substance with weight and elasticity. Flames extinguished, animals suffocated, and sounds diminished when air was removed. These observations revealed that air was composed of particles essential to life and combustion, challenging the ancient view of air as a simple, uniform element. Such discoveries were not isolated curiosities, they were part of a broader shift. Step by step, the world was being reimagined as material, structured, and governed by laws. Boyle stood at the forefront of this movement, applying the spirit of skepticism not to destroy but to build a firmer foundation for science. In doing so, he also redefined the role of the chemist. No longer a seeker of hidden elixirs or secret stones, the chemist became an investigator of matter itself, a craftsman of experiments, a discoverer of laws. Boyle's vision was not of a solitary alchemist guarding secrets in a dim workshop, but of a community of investigators sharing results, testing claims, and building collective knowledge. This was perhaps Boyle's greatest legacy, not only his specific ideas about particles and elements, but his vision of chemistry as a science grounded in clarity, experiment, and collaboration. The skepticism of the Sceptical Chymist was not a final word of doubt, but a call to inquiry. By questioning the false certainties of the past, Boyle invited future generations to seek the truths of nature through patient observation and reasoned thought. For centuries, alchemy had held the imagination of Europe. Cloaked in symbols and allegories, it promised not only material riches, the transmutation of base metals into gold, but also spiritual transformation, the purification of the soul, and the discovery of secret medicines capable of prolonging life. To many, the alchemist was a figure of awe, part philosopher, part magician, part artisan. But Boyle saw in alchemy both fascination and danger. Its practitioners often spoke in riddles, deliberately obscuring their meaning. Some hid behind metaphors of suns and moons, of lions and dragons, claiming to veil their secrets from the uninitiated. Others contradicted one another, producing competing systems of principles and elements that could not be reconciled. Where clarity was most needed, alchemy supplied confusion. This secrecy, Boyle argued, was deeply unscientific. Knowledge locked away in allegory could not be tested, refined, or corrected. It became a matter of private authority, not public demonstration. One alchemist's vision could neither confirm nor falsify another's. Progress was paralyzed and truth became indistinguishable from fable. Boyle's alternative was radical for his time: openness. A chemist should describe his experiments plainly, record his observations carefully, and share them so that others might verify or challenge them. Science was to be a communal enterprise, built not on authority or secrecy but on reproducibility. If a claim could not be tested, it could not be trusted. This ideal was not only philosophical, it was practical. Boyle himself published detailed accounts of his experiments, describing his apparatus, procedures, and results with unusual transparency. He was not afraid to admit uncertainty or to note anomalies. This candor set a new standard, one that would become the hallmark of modern science. By exposing alchemy's failings, Boyle also reshaped the identity of chemistry. No longer was it the pursuit of hidden stones and elixirs. Chemistry became the study of transformations of matter, how heat, pressure, solvents, and reactions altered the structure of corpuscles. It became a discipline concerned not with secrecy but with discovery, not with allegory but with demonstration. Boyle's skepticism was thus profoundly creative. By dismantling the false scaffolding of alchemy and Aristotelianism, he made room for chemistry to grow on solid ground. His critique was not a rejection of curiosity but a purification of it. The longing to understand matter remained, but it was redirected from superstition to experiment, from symbols to structures, from private revelation to public knowledge. This transformation extended beyond chemistry. Boyle's method embodied a broader cultural shift in the 17th century, the rise of the scientific method. Observation, experiment, and replication became the new currency of knowledge. The Royal Society, with its motto Nullius in verba, take nobody's word for it, captured this spirit. And Boyle was among its most influential members, embodying the principle that truth must be demonstrated, not merely declared. What Boyle achieved was not the final answer to the question of elements. Indeed, later generations would refine and revise his ideas. But his achievement lay in changing the terms of the question itself. No longer could one simply appeal to Aristotle or the authority of alchemical masters. The only authority that mattered was nature herself, interrogated through experiment. This was a profound reorientation. It meant that knowledge was not fixed but progressive. Each experiment could add to, refine, or even overturn what was known. Chemistry became not a closed system of secrets but an open journey of discovery. The effects of this reorientation were felt far beyond Boyle's own time. Within a century, Antoine Lavoisier would build on Boyle's skepticism to establish the modern concept of chemical elements, defined not by allegory but by experiment. Later still, Dalton would formalize the atomic theory, grounding it in the very corpuscular vision Boyle had sketched. The periodic table, the analysis of compounds, the vast edifice of modern chemistry, all would rise from the foundation Boyle had laid by daring to question. And yet, Boyle's legacy is not only in the theories that followed, but in the spirit of inquiry he exemplified. His skepticism was not cynicism. He did not dismiss the quest to understand nature. He refined it. He showed that doubt could be a tool of progress, that questioning tradition could open the path to truth, and that humility before experiment was greater wisdom than pride in authority. Thus, the Sceptical Chymist stands not only as a book of chemistry but as a manifesto of modern science. It reminds us that knowledge grows not from certainty but from questioning, not from secrecy but from openness, not from dogma but from discovery. By the end of the Sceptical Chymist, Boyle had not delivered a neat list of new elements. He had not replaced Aristotle's 4 or the alchemist's 3 with his own authoritative system. Instead, he had done something more important. He had shown that the old systems were inadequate, and he had laid down the principles by which a better understanding might be reached. His skepticism was not destructive cynicism, but a deliberate and disciplined tool. It cleared away illusions so that truth could be seen more clearly. It asked, how do we know this is true? Can it be shown, tested, repeated? In a world filled with superstition, secrecy, and second-hand authority, this was revolutionary. The ripple effects of Boyle's method spread far. His critique of elements inspired later chemists to define the term with precision. An element is a substance that cannot be broken down into simpler substances by chemical means. This definition, which seems obvious now, was radical in Boyle's time. From it, the modern list of elements was gradually built, leading to the periodic table and the systematic study of compounds. Boyle's corpuscular philosophy, though primitive by today's standards, pointed directly toward the atomic theory. John Dalton, in the early 19th century, would transform Boyle's cautious hypothesis into a robust framework, describing how atoms combine in fixed ratios to form compounds. Boyle's vision of particles shaping the properties of matter became the foundation on which modern chemistry still stands. Equally significant was Boyle's insistence on openness and experiment. The culture of science we now take for granted, sharing methods, publishing results, inviting scrutiny, owes much to Boyle's example. Without this openness, science would remain fragmented and stagnant. With it, knowledge became cumulative, growing across generations and across nations. But Boyle's lesson extends beyond chemistry. His work is a parable about the nature of knowledge itself. We live today in a world flooded with claims, some scientific, some political, some commercial. Like the alchemical texts of Boyle's age, many of these claims are cloaked in persuasive rhetoric, confident tone, or appealing metaphor. Yet Boyle would remind us, authority is not proof. Clarity matters. Reproducibility matters. Evidence matters. In that sense, Boyle's skepticism is as relevant in the 21st century as it was in the 17th. To navigate misinformation, we must ask his questions. What do you mean? How do you know? Can this be tested? The skeptical mind is not one that denies truth, but one that insists truth must be shown, not simply claimed. And there is another lesson in Boyle's legacy: humility. For all his brilliance, Boyle did not claim to have solved the riddle of matter. He admitted the limits of his knowledge, presented his ideas as hypotheses, and invited future thinkers to improve upon them. This humility is a mark of true science, the recognition that knowledge is always provisional, always open to refinement. From alchemy's riddles to Aristotle's elements, from corpuscles to atoms, from Boyle's laboratory to today's quantum chemistry, the journey of science has been one of questioning, testing, refining, and discovering. Boyle's The Sceptical Chymist stands as one of the turning points in that journey, a declaration that the path to truth lies not through tradition or secrecy, but through openness, skepticism, and experiment. So what, in the end, is the message of the Sceptical Chymist? It is this: do not accept without question. Seek clarity. Demand evidence. Embrace doubt not as an obstacle but as the beginning of discovery. Boyle did not find the final answers, but he showed us how to ask the right questions. And in science, in philosophy, in life, that is often the most important step of all.